Let's do these two examples of finding the conjugate, the real part, the imaginary part, and the magnitude of a complex vector. This first example is a vector in C2, and the second vector is in C3. Let's go ahead and begin with the first vector and finding its conjugate. The conjugate of a complex vector is just the vector whose components consist of the conjugates of the original components. So the conjugate of u is just 3 plus I and negative 2i. Recall that the conjugate of a complex number just negates its imaginary part. So the conjugate of a plus bi is a minus bi. The conjugate of 3 minus I is 3 plus I. The conjugate of 2i is negative 2i. Now, the real part of a complex vector is the vector whose components are the real parts of the components of the original vector. The imaginary part of a complex vector is the vector whose components are the imaginary parts of the components of the original vector. The real part of this component is 3. The real part of this component is 0. The imaginary part of this component is negative 1, and the imaginary part of this component is positive 2. So there those are. The real part of u is 3, 0, and the imaginary part of u is negative 1, 2. All we have left then is the magnitude of u. The magnitude of a complex vector is defined to be the square root of the vector's dot product with itself. So to dot u with itself, we need to take each of its components and multiply it by its own conjugate. That's how the complex dot product is defined. So we have the square root of 3 minus I times its conjugate plus 2i times its conjugate. 3 times 3 gives us 9, and negative I times positive I gives us positive 1. The middle terms cancel out. Then we have 2i times negative 2i, and that is positive 4. So this is the square root of 14. That's the magnitude of u. On to our second example. Getting right into the conjugate of this second example, the conjugate of 5 is just 5. The conjugate of 2 plus 3i is 2 minus 3i. And the conjugate of negative 1 minus 4i is negative 1 plus 4i. So that's the conjugate of u. The real part of u is 5, 2, negative 1. And the imaginary part of u is 0, 3, negative 4. So there those real and imaginary parts are. Remember that the imaginary part doesn't have the imaginary unit in it. The imaginary part just contains the coefficients of I in each of those components. Finally, the magnitude of this vector. Again, we have to dot it with itself, which means we need to take each component and multiply it by its conjugate, put that in a square root, and add them all together. The conjugate of 5 is 5, so we have 5 squared. The conjugate of 2 plus 3i is 2 minus 3i, so multiply those. And the conjugate of negative 1 minus 4i is negative 1 plus 4i. Then we just have to multiply all this stuff together, which gets us here. And finally, the final answer is square root of 55. Remember that because of the conjugates here, the middle terms, the 2 times negative 3i and 3i times 2, negative 1 times 4i and negative 4i times negative 1, those cancel out. So there's no imaginary units left in our answer. The magnitude of a complex vector is always going to be a nice real number. Let me know in the comments if you have any questions, and be sure to check out my linear algebra course and linear algebra exercises playlists in the description for more. Thanks for watching.
Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about. Stressed out, honey, I've been stressed out lately. Don't know what's what, don't know what I'm stressed about. Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about.